Hey there, everyone. This is Mr. Wood coming back with some more geometry extension lessons. This is our week 3 extension lesson for online learning. This is going to be talking about circles today. So we're going to be talking about different parts of a circle, some of the key vocabulary in a circle. We're going to be talking about some of the basic things that some of us probably already know about, like radius and diameter. And we're going to also talk about arcs and different types of angles that are actually inside of a circle and how they're related. So we're going to go ahead and start with some of the basics here. The first thing is the circle. So I've got a circle here, and we name a circle always by the central point. So whatever dot is in the exact center of the circle, that's how we would name this. So for this circle, we would just call this circle P, because P is the center dot, with that dot being in the center. So that is how we would name the circle. So if you're asked to name a circle, it's always whatever dot is in the center. That center point is a really key point for a lot of our vocabulary that comes next. For the next one, it's going to be radius. So a radius always starts at the center and then connects in a straight line to a point on the outside of the circle. So if I made a dot anywhere on the outside of the circle here, and I maybe called that point E, this would be a radius if I connected P to E in a straight line. Obviously, we're not going to zigzag through the circle or anything. It has to be in a straight line. And so the radius, this would be, E, P, E. So it would be segment PE here, would be our radius. The radius, usually R, right? And we call this a lowercase r, would be our radius. And again, it's from the center to the edge of the circle. However long that radius is, it's always going to be the same if I made another dot somewhere else. So let's say I put a dot over here, and I called this point Q. Then from P to Q is the exact same distance. In this case, we just called it R, as it is from P to E. So if P to E is 5 meters, then P to Q is also 5 meters. So the radius is always the same distance as any other radius on the figure. The diameter, another key vocabulary word that many of us are familiar with. A diameter is a line that crosses all the way through the circle from one point on the edge of the circle to another. So let's say I had point M, and I have point A. So our diameter, in this case, would be M to A. But what's key about the diameter and what's extremely important is that it does have to cross through the center. So the center is showing up again. If I put the dot over here and just connected them, that wouldn't work. That's not a diameter. Diameter must go through the center of the circle. So I have to go from M through P to point A. So it must go through the center, but this would be MA. The diameter is MA. Must go through center of circle. So that is a key. The diameter must go through the center of the circle. Let me move that over so you can see those words a little better there. Okay. So just like the radius has to connect to the center, the diameter also has to connect to the center. The diameter goes through the center and connects on both sides. So really what you have here is, if I split this in half, right, if P is the center, and from P to M is technically called a radius, right, from the center to the edge, and P to A is also called a radius. So really it takes 2 radii from one to the other to create one whole entire diameter, right? So 2 radius create 1 diameter. And that's a special relationship that we have. So the radius is always equal to half the diameter, or vice versa. The diameter equals 2 radii. So I'm just going to write those two equations down. Those are really important for solving, and we'll get to a couple examples real quickly. Okay, so the diameter, let's use the right color here. So diameter is equal to 2 radii. Or if I wanted to figure out kind of vice versa, if I was given the radius, I can find the diameter. If I was given the diameter, I cut that in half. So it's going to be the diameter divided by 2 will equal the radius. Okay? And I'll go through some numerical examples in just a minute here. The circumference, one more key vocabulary word here in this diagram, or another key vocabulary word, I should say. The circumference is the entire outside of the shape. So I kind of already have that drawn, right? The whole outside just creates the circle. So I'm just going to kind of make it a little bit more bold here. Okay, so the circumference is the outside of the shape, the whole outside of the circle. Outside, distance, or around the circle. So the circumference is like the outside, or it's around the circle. And there is a formula for that. So the circumference is equal to, circumference equals 2 times pi times the radius, right? So it's 2 pi r, 2 times pi, 3.14, times the radius. Or there's another formula. Again, we know that 2 times r is actually the same thing as diameter. So depending on what information you're given, the circumference could also equal pi times the diameter. These are the same equation, right? Because 2r, and d are the same thing. Diameter is 2r, 2r is diameter. So depending on what information you're given in your problem, it's going to be which one of these two formulas if I'm asking you for the circumference. The last thing is, what happens if I do have a line segment that doesn't actually cross through the center of our circle? So let me draw an example of that. Let's say I have Z here, a big line here, call that Y. And if I connect Y to Z, I create a line segment that is not a radius because it does not connect to the center. It is not a diameter because it does not connect to the center. It is a line segment inside of our circle. And so this is what we call a chord. A chord, this would be YZ, segment YZ. And a chord is a line segment inside the circle, but does not pass, not through center. This is a line segment that is inside the circle that does not pass through the center of the circle. And this is what we would call a chord. So a couple of numerical examples here. If I just kind of make up a couple examples real quickly for us. If I wanted to name them or find the values, there's a bunch of different things you could do. Okay, so make a circle. Let's say this right here from, call this P again, P to N. If I say P to N is 7. Okay, so, and I asked you to find a couple different values. If I asked you to figure out, okay, what is the radius, R? What is the diameter, D? And what is the circumference, a capital C? The radius, we already know. That's the information we're given because we know the radius is from the center to the edge. That's the definition of radius. So in this case, we actually already know the radius. It is 7. And we'll just say 7 units since we don't necessarily have a unit of measurement here. I know the diameter is 2 times r. So if I know what r is, then I know what d is. I know 7 times 2 is 14. And I know what the circumference is. The circumference is 2 times the radius times pi. 2 times the radius, 2 times 7 is 14, or I could just say pi d. Once you know what the diameter is, you can find the circumference by just putting that number 14 times pi. I'm just going to leave it in terms of pi. I'm not going to type pi into my calculator or anything. I'm just going to call the circumference 14 pi. And that's a very quick and easy way of solving for these 3 different values. Just going backwards real quickly, if I knew that I'm going to create one more example for you. Okay. If I know that this entire distance is, let's call that 24 from X to R in circle C. Okay, so this is circle C, and the distance from X to R is 24. Again, I asked myself, does this go through the center? If it does, then it is a diameter. Okay, so if I'm asking what's the radius, what's the diameter, and what's the circumference, the diameter is given to me. It's 24 units. That's in my diagram. The radius I know is only half of it from C to R. Again, if I know what the diameter is, I cut it in half to get radius. So I know the diameter is 24. I cut that in half. It gives me 12 units. There's my radius. And the circumference is just 24 pi. It's the diameter times pi, or 2 times the radius times pi, 24 pi. As for a chord, if I gave you an example, okay, one more example here. So this is, let's call this circle P again. And I draw a chord from A to B. I've got chord AB. The problem with this is the chord doesn't have any special relationship in regards to radius, in regards to circumference, or anything like that, or diameter. So at this point, even if I knew how long this was, let's say it was 10, if I knew how long the chord was, I still don't know what the diameter is, what the circumference is, what the radius is. I'd have to do a lot more in-depth math that we're not getting to just yet. So the chord does not have any special relationship. There's nothing I can answer from here. So this is the basics of a circle: radius, diameter, circumference, chord. How do we name a circle? How do we name a radius, a diameter, and how do we name a chord? They're all line segments except for the circle. They have these special relationships of circumference is 2 pi r or pi d, and their relationship between diameter and radius. So you're going to have some practice problems in the extension section to help practice this skill a little bit. And I'm going to create another video that goes over some of the arcs. We're going to talk about arcs and how to name them, and some angles that are inside of these figures. So check out that other week 3 extension video that's posted, and that will help you solve the rest of the problems on the assignment. And I'll see you over at the next video.